Hi, welcome back to the Shiko Math Practice Lab, Learning Through Practicing. And this video, we are still working on the implicit differentiation. This is our practice set number 2 here. And in this video, we're going to talk about how to find the derivatives of inverse functions. And it's a very important topic. And also, if you know how to use the implicit differentiation, find the derivative of inverse function, it can save you a lot of effort. Try to remember, some of the inverse function, like the derivative formula here. Okay, so let's go ahead and take a look at what type of the problem and we're going to have. And before that, I like to just do a very brief review about what is the implicit, how do we use the implicit differentiation method try to find the inverse functions here, right? Okay, so we're going to do several the inverse function about the trig function in this practice. So let me try to do a brief review, and I think most of you learned this inverse function and either in algebra 2 or in the pre-calc. So we say f of x is a function, so f inverse, right? So this is the inverse function. This is the inverse functions of the f of x. So one of the key things we know, that means that f and f inverse. So if you put them together, right? So it is supposed to be what? So that means it's supposed to be x. So it seems like we say f and f inverse, they cancel each other out, right? So that's why it's x here. So if you use the domain, the range concept here, right? So if you have some number here, right? So some number here, let's put the circles here. And then we say, if this relation, right? So if you go like this, this is what we call it is the f of the relation. And then if you go backward, if you go this way, right? So if you go this way, this is what we call this f inverse relation here, all right? Okay, so now that's just a very basic review about the inverse. We're going to learn how to do that. Like we say in this practice set, we're going to do several like trig functions. So let's take a look. So if, so this is another reviews here. So what is that means here? So if I say y is equal to the arcsine x. So what's that mean? That means if you take the sine y, this will give you the what? It's the value of x here, right? So that means if you have a right triangles here, then this will be your angle y here. So the sine y equal to x, right? So x, so sine is opposite over hypotenuse. So this is x, this is 1. So then by the Pythagorean theorem, so this will be 1 minus x squared. So that's why, that's what is the relation we say y is equal to arcsine x, and then the sine y equal to x. The same idea you can apply to the cosine, arccosine, or arctangents, right? So it's very similar here. Okay, let's take a look at our first, the first examples here. So first problem here, I want to find y prime by using the implicit differentiation. Of course, some students say, hey, the textbook give me the formula for the arctangent. Yes, it does, right? So, but sometimes when you take the test, your teacher will not allow you to use the formula sheets. And then how do you do that? Like I said, in here, let's, if you know how to use the implicit differentiation concept, in fact, you don't need to remember those bunch formula here, right? Okay, so now let's take a look. This is the ideas, right? So this is y equal to the arctangent x squared, okay? So what's that mean? Just like we did a review, that means the x squared is equal to what? Is the tangent what? Is the tangent y here. So far, so good? Okay, so now in here, you say, okay, this is the right triangles, right? So this is the angle y. And so the tangent, so what is the tangent? Is opposite over adjacent. So what is the tangent here? So this is x squared, right? So this is x squared, this is 1. So what is the hypotenuse here by the Pythagorean? So it's 1 plus what? X to the 4th. All right. Okay, so now from here on, okay, so I get my triangle down. So now from here, I want to find the derivative. So I take the derivative of both sides. So x squared is what? Is 2x. Okay, so remember, what is the tangent here? Tangent, the derivative is what? Is the second square y, correct? But because of y is a function of x, so what do we need to do here? We need to have a dy dx, correct? Okay, so now I can say the dy dx is equal to the second square y over the 2x here, okay? So the second square y is equal to the 2x. So this will be the 2x. What is the second square? Second square is 1 over cosine, correct? So the second 1 over second square really is just the 2x times what? Cosine square y. Okay, so the cosine square y, so let's take a look. What is a cosine? Cosine is adjacent over hypotenuse. So it's adjacent is 1, hypotenuse is 1 plus x fourth. Right, so the final answer for the dy dx here is equal to the 2x 1 plus x fourth. Right, so it's pretty easy, right, by using the implicit differentiation concept. Then you don't need to remember the formula, okay? So now let's take a look at the second ones here. So the second ones here, let's take a look. Okay, so the second one, let's go to the next page here. So this is the one we say y equal to the arcsine 2x plus 1. Okay, so let's do it one more time. What's that mean? So that means the sine y is equal to what? It's 2x plus 1, correct? Okay, so now let's do a triangle. So this is y. Sine is opposite over hypotenuse. So it's 2x plus 1. So what is here? So this side is 2x plus 1. This one is 1. Okay, so what is this one? Pythagorean's theory will be 1 minus 2x plus 1 to the what? To the squares, right? Okay, so now after we do that, then we say, okay, let's check the derivative. Sine y, what is the sine y derivative? It's a cosine y, right? We did many our previous practice how to find implicit differentiation. Then every time I take a y, what I need here? Y prime here, right? Okay, so now the 2x take a derivative is what? Is 2. 1 take a derivative is 0. So now I have the dy dx is equal to what? 2 over cosine y here, right? So the 2 over cosine y, so this is 2 over, so what is the cosine y? Is the 1 minus 2x plus 1 to the square over 1, right? So that means my final answer, so this is 2 over 1 minus 2x plus 1 to the square. Some people want to simplify a little bit more, then you will get this is 2, and this will be 1 minus, you just FOIL it. So it's 4x squared minus 4x plus 1 plus 4x plus 1. So 1, 1 cancel. So you will get this is 2. Then this is a negative 4x squared minus 4x, right? And then you can factor the 2 out. So this is will be 2. So this will be the negative x squared minus x. So this is 1 over negative x squared minus x, right? So If you want, you can simplify it. Or, I think it is good enough if you just leave the answer in here. Okay, so that'd be good. All right. So like I said, this one, if you use the implicit differentiation, it's very easy. You don't need to remember those fancy formula. Okay, so now let's take a look at the third one here. This one is a little bit complicated. I have two functions here, right? So this is y equal to the cosine inverse arcsine, cosine, and here is arcsine. This is t here. All right. So the same way is here, right? So this is y equal to, so that means I can change, this is a cosine, arc cosines, right? So that means what I can do here, so I can change it, that means the cosine y, right, is equal to what? Is equal to the arcsine, what? Arcsine t, all right? So that means the cosine y is equal to the arcsine t here. And now in here, this is an other, right? It's an other inverse. So that means, so this is inverse so for the arcsines, right? So I can do this, I can say, so this will be what? This will be the sine, cosine y. And what is here? Is t here. Okay. Okay. So now let's try. Okay. So let's try to find the. Okay. So let's try to find the triangles here. Right. So, okay. So this one's here. Oh boy. So this. Let me draw better pictures here. Okay. So this one's here. I'm going to find the first triangles here, right? So the first triangles here, this is the, so this is a sine cosine y, right? Is equal to t. So I know this is the cosine y, right? So whatever this angle is, cosine y is t, right? So the t, that means this is t over 1. Right, sines here, right? So it's the sine here, right? So be careful here. Let me color coding here. So this is cosine, so this is angle. All right, so now this is 1. So what is here? Pythagorean theory is 1 minus t squared. Okay, and now I'm going to back to here, right? So then I have another triangles here. And this is the triangle. I'm color coding here. This is cosine y, right? Okay, so that means if this angle is y, what I have here, I have arcsine t, right? So this is cosine. Cosine is adjacent over hypotenuse. So that means adjacent here is arcsine t. And here hypotenuse 1. Then the Pythagorean theory is 1 minus arcsine t to the square. All right. Okay. So now, okay, we got the ball. As soon as you got the triangles done, then you almost got the answer. Okay. Now let's take a look at the derivative. All right. So first one, I need to take the derivative of sine. So what is the derivative of sine? Is cosine y. Correct. And then I need to change rule the cosine. What is the cosine? Is negative sine y. Okay. After that, remember y is a function of what? Y is a function of x, or here is t. So I have what? Y prime. All right. So it's equal to 1 here. Okay. So now let's take a look here. So cosine. Okay. So here cosine y. That means my angle is cosine y. So I need to use these angles, right? Okay, so that's the color coding. What is the cosine? Is adjacent over hypotenuse. So it's 1 minus t squared. Okay, now times negative sine y here, right? So I times the negative sine y. So what is the sine y? Okay, sine is here, right? So it's times the negative sine y. So that means I'm times here. Okay, so far so good. Okay, so now here, this is my sine y here. So what is that? So you times the negative sine, right? So it's negative 1 minus arc sine t, the whole thing square, times what? Times y prime, right? Equal to 1. So what is my y prime is? My y prime will just be what? The whole things here. This is 1 minus t square and times 1 minus arc sine t squares, right? So that's it. Okay, so that's how do you use the implicit differentiation and try to find the inverse function. Okay, so now let's take a look at the next ones here. This one is a very, very important problem. I almost thought almost every teacher, they always like to put one of those problems on the tests here. Okay, so let's say, suppose one is the one-to-one differentiable function. The reason why they want to specifically mention the one-to-one is because then the F inverse has to have a one-to-one relations, right? So they want to see what is the value of F inverse you take the derivative, right? So it's what is the first derivative of the F inverses here. Okay, so now let's take a look. So here, remember F inverse and F, right? So if you put these two together, just like in the review, we know the F and F inverse seems it's just what? It's just cancel, right? So it's just be the X itself. Okay, so now let's take the derivative. Okay, so the derivative of the left-hand side, this will be F prime, F inverse, X. Hey, don't forget, I have this number inside, right? So what rule I'm using? I need to use the chain rule, right? So this is F inverse X and the primes here, right? So let me color coding that so you will not get confused here. So let's from here to here, this one here is the chain rule, right? Because you have something there. And then the right-hand side is 1. Okay, so then this one is really pretty easy. So the F inverse X, so what is the derivative of the F inverse? Well, will just be 1 over F prime F inverse X. All right, so now let's take a look at the problems here. Okay, now let's see how do we substitute the value. Okay, so the first numbers, they tell you F4 equal to 5. Okay, so F4 equal to 5. So that means if this is 4 and this is 5, right? So F4, so this directions, right? So this directions, this direction is the F, right? So this is F4 equal to 5. So I know the backward direction. So what is that? That is what? That is F inverse, right? So that means F of what? F of 5 going to equal to what? F of inverse 5, you go backward, will be equal to what? Be equal to 4. All right? Okay, so now let's see this relation because the problem wanted to find F inverse 5, right? Okay, so that means X equal to 5. So this is 1 over F prime F inverse 5. Okay, so now I say, oh, F inverse 5 is what? It's 4. So this is become F prime for the 4. Oh, they tell us F prime to the 4 is 2/3. So it's 1 over 2/3. So what is the answer here? It's 3/2 here. Okay? So that is kind of like so this is a very, very important formula, right? So how do you find the inverse derivative? Like I said, you don't need to remember if you understand the basic concept, right? The inverse and by the function, then you take the derivative of both sides. You can derive it. Like I said, this type of problem, I don't know why almost all the teachers, they like to put this type of problems on the exams. And so maybe it's try to test your understanding, right? Okay, so now let's take a look at these ones here. So let's say f of x equal to x plus ex is also a one-to-one function. The reason why they want to find a one-to-one function is because it's the inverse, right? So we already, from the previous, we know the inverse x the derivative of the inverse x is equal to what? That's why I say you need to know this formula. It's 1 over f prime and f inverse x. Okay. Okay, so now we are looking for f inverse 1s here. Okay, so that means I'm looking for f prime, f inverse 1, then the derivative. So basically, so this will be, this is f prime, and this is f inverse 1. Okay, okay, so now let's take a look here, right? So this is a very good problems here. So I know, okay, so f inverse 1, that means, so here I have some number a, right? So this is 1, right? So that means if you go like we say, if you go this direction, so this is f, right? So it's f of a give you 1. So if you go the back direction, what is this? This is f inverse 1, right? So you want to find 1. Okay, so now let's take a look at these ones here. This one is a little tricky here. So that means f of a, so that means the a plus ea is equal to 1 here, okay? So for this 1 here, so what is the a going to satisfy this equation here? Okay, so in here you can try the arrows here. So the a's here is will be what? If you try a is equal to 0, so you will see the f0 is equal to the 0 plus e to the 0. I know the e to the 0 is what? It's 1. And a lot of students will say, why you try 0? Like I said here, you know, this is not really a good way to solve it. And so it's kind of like you try the a equal to 0 and the 1 and to see, you know, so this one is not say you be able to solve it. Okay, so that's why you just try the arrow, you find, you know, when a is equal to 0, it satisfies. So, well, that's good, right? So now I know that f inverse 1 equal to what? Is 0. That means when a equal to 0. Okay, so that is what you get the answer for this one. So you said f inverse 1 is 0. Okay, so now you will have these numbers here. So you say f prime, f inverse 1, so it's 0. Okay, so how do I find the f prime? So the f of x is equal to the x plus ex here, right? So f prime will just be what? Will just be 1 plus what? Ex, right? Because the exponential derivative is itself. So f prime 0 is 1 plus e0. So it's what is 2. Okay, so the answer is 1 over 2. Okay, and that's it. And that is the, you know, for these two practice sets, basically covered all the possible scenario about the implicit differentiation. And if you kind of practice these two, and I think you will have a very solid background about the implicit differentiation here. All right, especially the last two problems here is in general. If I give you a function, how do you find the derivative of the inverse functions here? And then the first three problems are just like, you know, try to practice the implicit differentiation concept on the trig function as well. Like I say, you know, they are the formula already derived for the inverse trig function, but it, you know, if you know how to use the implicit differentiation skill, you don't need to remember those formulas. All right, that's it. And I hope that you got a very good understanding about the implicit differentiation. All right, and nice to talk to you about this topic. And so you have a good day, and looking forward to talk to you in the next topics here. Okay, bye.